Hello students, welcome to the IMS GATE Academy. So this will be the last lecture that we are going to see in the electrical machine, and we have almost completed a total of 9 lecture, and this will be the last lecture, which is lecture number 10. So those who have not watched those lecture till yet, please do visit the those lecture. Definitely you will going to enjoy all those lecture, and whatever topic that we have discussed is basically related to the basics of the electrical machine, or that is why the reason the course name is foundation course. So I hope that you are enjoyed a lot and enjoying as well as right now, and there are many more subjects which are about to become. So please be stay tuned with the IMS GATE Academy channel. Definitely you will going to have a great experience with our faculty. All right, so the last topic that I'm going to take is of the two-phase rotating machine, and as well as I have come up with one more topic, that is double field revolving theory. So I know most of the students have a confusion regarding the double field theory, that what is sir double field theory, and how we will going to cope up with those topic. All right, so let me give you one idea regarding this. A double field revolving theory is a kind of study where we need to be discussed in the single phase induction motor. All right, so single phase induction motor is basically is not a self starting motor, and why that single phase induction motor is not a self starting motor, how we will come to know that. Only the concept behind is that double field revolving theory. So from the double field revolving theory, it gives us an idea that why single phase induction motor is not a self starting motor. All right, so let us begin with the lecture number 10. Okay, two phase rotating magnetic field and the double field revolving theory. So first I will take up two phase revolving two phase rotating field, and after that we'll discuss the double field revolving theory. All right, now here we have a unlike a three phase winding, here I will take a two phase, where this is one phase A and A dash, and this is one another phase B and B dash. So in the last lecture I told you that A and A dash is basically what? A conductor which is carrying the same current. All right, so from the conductor A, the current will going to become outward or inward, and in conductor A dash it will be inward and outward, means just opposite to this one, because the current can flow only in the closed path. So if one current is forward, then the same current has to be come at the back side. All right, so in the same way we have one more conductor, basically one more phases B and B dash, which is having what? A kind of coil. All right, so what is the difference between a conductor and a coil? A two conductor is basically a one turn, and if you are making a number of turns greater than equal to 2, then that turns now become the coil. All right, so the basic difference is between the turns and the coil is that a coil is having n number of turns, and one turn is having two conductor. All right, so see, like your three phase unlike your three phase winding, where to generate a three phase rotating magnetic field, we should place the three winding at 120 degree electrical, or 120 degree mechanical, or you can say in space A, B and C. Done. And also the current flowing through those phases has to be 120 degree apart. So using the same concept here, with the two phases, the one phase will carry the current as Im sin omega t, and the other phase has to phase displaced a current by an angle of 90 degree. All right, so that phase is that phase displaced has to be lagging in nature. All right, this kind of concept we have already studied in the three phase winding. All right, and also the placement of the winding should be 90 degree, with respect to space. All right, so see, if this is an axis of the 0 degree, like 0 degree, then this winding B is kept exactly at 90 degree. So all the two conditions are fulfilled. The space angle between the two winding is 90 degree, and let me take a current for phase A. IA. Okay, this is equal to Im, which is peak value sine omega t. Then in the phase B current, it has to lag the IA current by an angle of what? 90 degree. All right, done. Now, as we know that if any alternating current flows through the conductor or through the coil, then it will generate a magnetic flux. Now, what I want my flux to be such that just a second. To be such that FA, flux due to current IA, should be horizontal, and flux due to current IB, I want this to be vertical. Okay, so this is MMF due to A current and MMF due to B current, and the difference between these two MMF is what? 90 degree, because the current is what? 90 degree phase dispelled. So FA is nothing but number of turns in A coil. Let me take it as N, and IA current is what? Im sine omega t. So this N Im, let me take it as maximum MMF sine omega t, and using the same concept, MMF due to current IB or current due to phase B, it will be equal to FM sine omega t minus 90 degree. Now, one question is that what should be the direction in the what should be the direction of the current in the coil such that we are going to get this MMF, or the direction of EMF should be this one. See, we will going to use the Fleming right hand palm rule. Point your thumb in the direction of MMF or flux or magnetic field. Then this forefinger will curl in a direction of current. So this MMF due to current in phase A. So MMF should be here. Then current should be from here. A coil, it should be outward. Means outward from the board, and from A dash it has to be inward or into the board. All right. So if it is coming towards us, so you will see it as a dot. Please let me know whether this is visible or not, or it is better that I should change this color. So this will be dot, and here it will be cross. Done. So it will give FA in this direction. What about FB? I want FB in the downward direction. Then point the thumb in the downward direction. Then this forefinger will give you the direction of current. So here it is entering, so it will be cross, and here current will come outward, or it is coming towards you. So you will see it as a dot. Done. So if you make the direction of current in such a way that it is marked over here, then you will going to get the MMF like this. Done. Now we are good to go with how we will going to see the rotating magnetic field in two-phase winding. Okay. So let me take an instant. Let me take a case 3. Okay. So in the first case, we will take omega t equal to 0 degree. Omega t equal to 0 degree. Then your FA which is FM sine omega t, it becomes 0, isn't it? And FB, this will be what? FM sine omega t minus 90 degree. Done. So this value will be what? Sine of minus 90 is minus sine 90, so it will become minus Fm. All right. Now here Fa is 0 means it will not going to make a participation in a magnetic field, whereas Fb will going to give the total magnetic field. But the direction has to be negative, because for the positive MMF due to B coil I have taken downward. Then for the minus Fb it has to be upward. This we have seen in the 3-phase rotating magnetic field. So the direction here will be what? For Fa it should be 0, and for Fb it should be opposite to the direction that we have assumed. So it will be upward. This is Fb, which is equal to Fm. Please do not write minus Fm, because minus sign we have included in the direction. All right. Now, if you find the resultant MMF here, okay, let me write here Fr, that is resultant MMF. So this MMF is due to MMF A plus MMF B. Now this is equal to what? Fm. So in the first case, the resultant MMF due to both the phases is what? Having Fm as the amplitude. Let us move to the next part, which is at omega t equal to 90. So Fa, which is equal to Fm sin omega t, so you will get Fm. And here Fb, which is Fm sin omega t minus 90, so you will get 0. So in this case, your Fa is Fm, so positive, so we will have to make in the same direction. Just a second. Done. And Fb is what? 0. So this is Fa, which is equal to Fm, and your Fb is what? 0. So this will be the direction. Now let me take our next case, which is omega t equal to 180 degrees. So your Fa, which is Fm sin omega t, so sin 180 is 0. Fb, Fm sin omega t minus 90, so you will get Fm. Now here Fb is positive, so we will have to draw in downward direction. All right. So here Fb is positive, which is equal to Fm, and your Fa is what? 0. Now what would be the resultant MMF, which is Fr? Fr is due to both the MMF F and Fb, so this is equal to Fm. In the previous case, Fr will be what? Fa plus Fm, which is, sorry, Fa plus Fb, which is Fm. So everywhere, in all the 3 instances, we have seen that F resultant is having the amplitude of Fm, which is the maximum MMF, all right, which is the maximum MMF. Now, if we closely observe the direction, at omega equal to 0, it is upward. At omega t equal to 90, it is horizontal, and at omega t equal to 180 degree, it is downward. So it is very clear that whenever the timing or whenever the time is changing, the magnetic field or the MMF is rotating in the clockwise direction. Done. So in this way, you will going to find the rotating magnetic field in 2 phases. But the condition is that the winding should be placed at 90 degree in space, and also the current flowing in both the winding should be sinusoidal, and one current should be lagging with respect to other at an angle of 90 degree. So let us come to the next part, which is two-phase reverse rotating magnetic field. So as we have seen in the three-phase reverse rotating magnetic field, the same concept we will going to be apply. Here what I will take, here IA current I will take as Im sine omega t minus 90 degree, and IB is Im sine omega t. So what I have did here, I have interchanged or I have swapped the current. What I mean to say that earlier at coil A we are having the current, we were having the current as Ia sine omega t, but this time it is sine omega t minus 90 degree. So what it implies? It implies that earlier in coil A we have sent the current first, and exactly at delay of 90 degree we were sending the current which is in coil B, but at this time we are sending the current first in coil B, and just after 90 degree we are sending the current in coil A. So this is the meaning of minus sign here. Okay, this minus sign is basically a delay. All right, so what I want here, the conventional MMF direction should be like this. I want my conventional direction of MMF should be like this. Just a second. Okay, so this is FA and this is FB. All right, now one thing I should make it clear is that the coil A and A dash, the name given here is not by the current. Means earlier some may think that the current here is flowing as IA. So because of that current we have named this coil as A dash. No, I can give the name here as X dash or Y dash, and in both the cases the current, let us take Im sin omega t. All right. So the coil name and the current will means the coil name will not going to decide the rotation of the current. Oh, sorry, the rotation of the magnetic field. It is only the current who is going to decide the rotation of magnetic field. All right. So I can name anything X dash, Y dash, Z dash, but only matter is that what current we are giving at this particular coil. Done. So I want my FA in this direction and FB in this direction. So what should be the current here? Here it has to be dot and here it has to be cross, and similarly here it has to be dot and here cross. Done. Now let us find the MMF FA. This is equal to n Im sine omega t minus 90. So this becomes Fm sine omega t minus 90 degree, and FB, this is equal to Fm sine omega t. All right. So let us take case A. So your FA is now become 0 degree. So 0 minus 90 is minus 90. Sorry, minus of sine 90. So it becomes minus Fm, and your FB becomes 0. So minus Fm implies the opposite direction. So FA we have made earlier. FA we have made earlier here. So it start with in this direction. Done. And your FA, sorry, FB is 0. And your FA, this was equal to Fm. As I have said there, please do not write minus Fm. The minus sign we have included in the direction. Now let us find the resultant Fr. Fr is equal to Fa plus FB. So this is equal to Fm. Done. Case second, Fa, this is equal to 0, and FB, this is equal to FM. So what it gives? FB means downward direction, and FA is 0. FA is 0 and your FB is FM. So your resultant MMF will be what? This is equal to FM. Done. Let us take the last case, which is omega t equal to 180 degree. So your FA in this case, which is FM sin omega t minus 90. So you will get FM, and FB, which is FM sin omega t. So you will get 0. So since FA is positive, so this will be your FA, which is equal to FM, and FB is what? 0. So your resultant, just a second. So your resultant MMF FR is equal to FM. Okay, sum of both the MMFs. Now, if you closely observe, by changing the omega t or by changing the time, by changing the time, we are observing that your magnetic field or MMF is first starting from the left side, then it goes to downward, and again it comes to the right side. So this time the rotation is what? Anti-clockwise. Earlier it was clockwise, but this time it is anti-clockwise. So it is very clear that if you want the direction of the magnetic field in clockwise, then phase A current should be lead the phase B current, whereas if you want the current to be rotated in anti-clockwise direction, then in that case the phase B current should be lead by an angle 90 degree with respect to phase A current. Done. So this is all about the two-phase rotating magnetic field in the forward and backward direction. Alright, now let us come to the next topic, which is one of the important topic in the electrical machine, which is known as double field revolving theory. Basically, this is double field revolving theory. Okay, this is double field revolving theory. All right. Done. So what do you mean by double field revolving theory? Now see, we have a current here, and this current will going to generate an MMF flux or magnetic field. But is it possible that this MMF may have some effect at this point, or at this point, or at this point? Then if there is an effect due to this MMF, then what should be that effect that I want to know? Then how we will going to find? We will going to find by using the concept of double field revolving theory. All right, so let me take the current here as dot, as we have discussed in the last lecture. So it will be cross, here dot will come, here cross will come, here dot will come, and here cross will come. Done. So what will be the MMF in this case? MMF will be FA here, FB here, and FC here. This is FA, FB, and FC. And the difference was 120 degree. This we have seen in the last lecture. So your FA is equal to what? FM cos omega t. You can take sine, you can take cos, but but if you take the sine term, then there will be one difficulty. Okay, just to avoid that, I have taken the cos term here. All right. Otherwise, at last we will have to convert the sine into cos or cos into sine. That work I want to remove. All right. So your FB, this will become IF cos omega t minus 120 degree, and your FC is FM cos omega t minus 240 or plus 120 degree, both are same. Done? All right. So I want to see the effect. Just a second. Okay, I want to see the effect of all the MMF at this particular space angle. Basically, if you take this as a reference, so at this space angle, I want to see the effect of all the MMF. All right. Now let me take this angle as theta. This angle as theta. Now, if you resolve all the MMF at this axis, you will going to get FA as FA cos theta, isn't it? Let me write it as small fa. This will be FA cos theta. And what about FB? FB will be, see, this is FB. So, this angle will be what? From here to here. This will be theta minus 120 degree. And what about this angle from here to here? This angle will be theta plus 120 degree. So, if you resolve FB, you will going to get capital FB cos of theta minus 120 degree. And what about FC? FC will be capital FC cos of theta plus 120 degree. So, substitute all the values. FA is FM cos omega t here. So, you will get, let me change the color. So, you will get capital FA is equal to FM sin omega t, FM sin omega t cos theta. FB FM, sorry, not sin, cos, it is cos omega t. So, FM cos omega t minus 120 degree and cos theta minus 120 degree. And what about FC? FC will be FM cos of omega t minus 240 or plus 120, both are same, cos of theta plus 120. All right. So, this is basically what? This is the phasor diagram or a vector diagram. This is the phasor diagram or vector diagram. This is the vector diagram. Now, the basic difference between the phasor diagram and vector diagram is that the phasor diagram is drawn by varying an angle omega t, which is electrical angle, And if you are varying an electrical angle, then it is known as phasor diagram. But if you are varying an space angle or mechanical angle, then it will be known as vector diagram. So the basic difference between the phasor and vector is that. All right, so let me come here. Okay. So if you closely observe all the MMFs, your MMF A is the combination of your time and the space angle. So your amplitude of each and every MMF depend on the space angle as well as electrical angle. So this will going to give you what? A double field theory concept. Whenever we are going to have two term omega t and theta, from there you will going to get a double field revolving concept, and as well as one more concept you are going to get, that is standing wave. What is standing wave? Just after of couple of minutes I will let you know, but as of now let us stick to here. Here we are having the two parameters, so let us resolve here that how we will going to see. So by changing omega t, let me take here, I am taking only case A, which is FA. Just a second. I am changing only case A, sorry, FA. So let omega t equal to 0 degree. Okay, the first instant means as soon as you have given the current, then what will be the MMF value of the phase A with respect to space angle? So this will become what? This will become FA, this will become FM cos theta. Okay, so this will be theta and this is FA. So its variation will be like this. Isn't it? So this is FM. So you have fixed the amplitude omega t at 0 degree, which is plus FM. Now let us take one more instant B. Let omega t equal to 60 degree. So your FA will be what? Cos 60 is what? Half. So this will become FM by 2. FM by 2 cos theta. So if you plot here, with respect to theta, sorry, with respect to theta, this is FA with respect to theta, you will get amplitude now as FM by 2 cos theta. So here the amplitude is reduced, FM by 2. But in all the cases, in both the cases, the nature will be cosine, but only what? The difference is in the amplitude. Earlier it was FM, but now it is FM by 2. Now let me take the last case, omega t equal to 120 degree. So your FA will now become what? Cos 120 is what? Minus cos 60, and minus cos 60 is minus half. So you will get minus FM by 2. So this time the wave shape is like this. Okay, this is FA and this is theta. So this time it is minus FM by 2. So it will start from negative direction. Done. Now if you combine all these cases, if you combine all the three, sorry, this is case, wait a second, this is C. Okay. Now, if you combine A, B and C and vary with respect to time, which is omega t, then you will going to see that at omega t equal to 0, your wave was like this. This is for omega t equal to 0 degree. Then what about omega t equal to 1, what about at omega t equal to 180 degree? It will be like this. Done. Now let me take omega t equal to 60 degree. So for 60 degree, it will be like this. And for 120 degree, it was minus Fm by 2. So it will start from here. Okay, so this is minus Fm by 2. Okay, just a second. This is plus Fm by 2. This was Fm and this was minus Fm. Done. Now what we are observing here? What we are observing here? We are observing that whenever we are changing the time from 0 second or 0 millisecond and so on and so forth, we are seeing that your cos theta wave shape is what? It is changing, but it is what? It is oscillating in the same axis, alright? It is oscillating, means if you are changing theta, then your point at this omega t equal to 0 degree, it is changing in this axis only, okay? It is like a wave shape, or it is like a wave in an ocean. A wave in an ocean is what? Basically, whenever a wave is coming in an ocean, it will be oscillating or jerking in the same position. So the same thing is happening here. Whenever the time is changing, each and every point of the same MMF, which is FA, is oscillating in this axis. Done. So you will see that or it will look like that your wave is generating, means basically that cos theta is looking like a wave. Done. Now what do you mean by traveling wave? A traveling wave is an is basically a phenomena where the amplitude is changing at the same position. Here at the origin, the amplitude is changing from Fm to Fm by 2, then 0, then minus Fm by 2, then minus Fm, but at the same axis whenever you are changing the time. So this is nothing but the traveling wave. Done. Okay, so the traveling wave is basically, if you look at here, it is having the positive value and it is having the negative value. It is having the positive value and it is having the negative value. So how we have got? We have got from FA, FB, means basically from FA, let me give you a task for FB and FC, and please do check whether you are also getting the same wave shape or not. Alright. Now let me discuss about a traveling wave. What is traveling wave here? And to understand this, let me resolve the component FA, which was Fm cos omega t cos theta minus, sorry, cos theta, na? So if you resolve this, just a second, okay, if you resolve this into cos term, multiply by 2, divide by 2. So 2 cos A cos B will be what? Cos A plus B, cos A minus B. So it becomes Fm by 2. cos omega t plus theta, or let me write theta minus omega t. I have taken this as A and this as B, plus cos of theta plus omega t. Done. Now what about B? FB what? Fm cos omega t minus 120 degree cos theta minus 120 degree. So again resolving it, you will get Fm by 2 cos A plus B plus cos A minus B. So theta minus 120 and minus omega t minus 1 plus 120. So take this as A and this as B. You will get theta minus omega t plus cos theta plus, okay, wait a second, A minus B, no? Okay, so and A plus B. So theta plus omega t minus 240 degree. Done. Okay, let me take FC. FC will be what? Fm cos omega t plus 120 degree cos theta plus 120 degree. You can also take minus 240 in place of plus 120 degree. So if you resolve, you will going to get Fm by 2 cos of theta minus omega t plus cos of theta plus 240. Plus 240 is what? Minus 120 degrees, isn't it? So we have resolved the MMF, FA, FB and FC in terms of their two part. Done. Now if you take this FA only and let us analyze the thing, and whatever thing we are going to be discuss or will going to analyze from FA, the same will be carrying forward to the FB and FC. Now here the two waves is basically means FA will have a basically two parts, which is theta minus omega t and theta plus omega t. So the first part, let me add a page here. FA, which was Fm by 2 cos theta minus omega t and plus Fm by 2 cos of theta plus omega t. Now this part theta minus omega t, this is known as forward MMF. This is known as forward MMF. And theta plus omega t, this is known as backward MMF. All right, this kind of concept you have already discussed, or you will going to learn in the power system, where there is one chapter traveling waves. So this concept you are directly going to use in the power system also. All right, so please be specific or be clear about the concept. In case of any doubt, please comment in the chat box. I will reply as soon as possible. All right, so here the forward MMF and backward MMF is basically theta minus omega t and theta plus omega t respectively. But why this forward MMF name has been given? See, to understand this, let me take the first part A, or let me write 1. Let me write 1 here, which is Fm by 2 cos theta minus omega t. Now at omega t equal to 0, what will be the wave shape? It will be at omega t equal to 0, it will be like this. It will be cos, isn't it? It will be cos. Now in the second case, okay, in second case at omega t equal to, let us take 90 degree. So this will be equal to what? See, this will be 90. Wait a second. This will be 90 degree, 180, and this is 270 degree. So at omega t equal to 90, this means that what? It has got shifted. Yani what it means? This curve, this cosine curve, okay, this curve, cosine curve at omega t equal to 0 is now, it is shifted to this is 90 degree. Okay, it is shifted to here and it is start like this. Okay, so now this time it will become, wait a second, yeah. Now this time the curve will be like this for omega t equal to 90 degree. So what we can observe from this? What we can observe from this? Earlier it is starting from here, but this time it is starting at 90 degrees. So isn't it look like that this curve is shifted towards right hand side, or your curve is somewhat starting, or it has moved forward, isn't it? This curve has moved forward. So this is the reason why your theta minus omega t is known as forward MMF. Or also you can go by the signal system concept, where we use left shift and right shift. If you have a negative sign, then it is known as right shift. If you are having the positive sign, then it will be termed as a left shift. All right. So in this way, your theta plus omega t, let us check what is going to be happen to theta plus omega t. So your second part, which is Fm by 2 cos of theta plus omega t. So at omega t equal to 0 degree, this will be what? This will be simply cos theta. And this is 90 degree and this is 270 degree. Done. In the next case, at omega t equal to, let me take 90 degree. So what it becomes? Cos theta plus 90. Cos 90 plus theta is what? Minus sin theta, isn't it? It is minus sin theta. So if you see here, this will be minus 90, this is 0 degree, this will be 90, and so on. So this time your curve will going to start like this. For at omega t equal to 90 degree. So by looking into both the figure at omega t equal to 0 and at omega t equal to 90, the curve looks like it is starting from the backward. So this is a reason why this theta plus omega t term as backward MMF, whereas this is known as forward MMF. I hope this is clear to you. Okay, wait a second. All right. Now let us discuss about the speed. Okay, at what speed this field is rotating basically? At what speed this field, where it is? Yeah. At what speed this field is oscillating, or you can say here, at what speed the field is rotating? This field. This we need to find. How we will going to find? We are having one formula of speed of wave. Okay, means at what speed this wave is oscillating. So the formula here is what? Speed of wave is equal to C, coefficient of t term and coefficient of theta. Coefficient of theta. Now please observe this, or please pay attention here, otherwise it will going to above your head. Now coefficient of theta, if you look at the expression, sorry, of t, what is that? Omega. Okay, please ignore negative sign. Coefficient of theta is what? Omega. And what is the coefficient of theta? Coefficient of t is omega, then theta has a coefficient of 1. So this will be equal to omega. But this is electrical or mechanical speed. This is electrical speed. Whatever thing is written under the cos term or sine term are basically the electrical angle. So this is what? Electrical speed. Now how to convert this electrical speed into mechanical? Because I want the number of revolution in terms of per minute. Okay, I want the speed in terms of revolution per minute. How we are going to see that? So this is electrical. So to convert electrical into mechanical, we need to multiply. This is electrical speed. So if you multiply omega with 2 into pi, it becomes mechanical speed. Okay, so you can convert your electrical speed into mechanical speed by using this conversion. So please remember this formula. In some state exam, you may directly find this formula. Okay. So let us move ahead with the next part, which is double revolving field theory in three-phase reverse rotating magnetic field. Okay, wait a second. All right. So the next part is double revolving field theory in three-phase reverse. I think I have missed one slide. Okay, let me see. Yeah, FA I forgot here. What will be the resultant MMF? What will be the resultant MMF? Let me find here. Resultant MMF. Let me have one space. So resultant MMF, let me take FR. So this FR is equal to FA plus FB plus FC. So what is FA? Sorry, what was FA? FA was FM by 2 cos theta minus omega t plus cos theta plus omega t. What was FB value? FB value was FM by 2 cos of theta minus omega t plus cos of theta plus omega t minus 240 degree. Okay, this we have got, and Fc was Fm by 2 cos of theta minus omega t plus cos of theta plus omega t minus 120 degree. It was plus 240 and plus 240 can be written as minus 120 degree. Now, if you add all this, you will going to get, see, this term are same. So, this becomes 3 Fm by 2 cos of theta minus omega t plus. Now, if you add this part, cos theta plus omega t minus 240 and cos theta plus omega t minus 120, this will going to give a value as 0. This will going to give the value as 0. So, it will be directly 0. So, your resultant value is 3 Fm by 2 cos of theta minus omega t. Now, if you remember the last lecture, the resultant MMF that we have got for 3-phase rotating field was 3 Fm by 2. This we have got in this from this concept as well as. All right. If you directly go by using the pole concept or MMF concept without including the space angle, then you can directly get the magnitude as 3 Fm by 2. But to get the rotation, you will have to take the case omega t equal to 0, then omega t equal to 90 and so on and so forth. This we have discussed in the last lecture. But if you are going to use the if you are going to use the MMF, sorry, not an MMF, the electrical angle as well as space angle, means omega t as well as space angle, which is theta, then also you are going to get the amplitude as well as direction in the same expression. So, this cos theta minus omega t implies that your rotation is in clockwise direction. How, sir? See, earlier the theta that we have assumed, in which direction? From this axis, the theta is in clockwise direction. So, this 3 Fm by 2 is basically 3 Fm by 2 cos theta minus omega t. This basically is what? Forward direction, means clockwise direction. And in the last lecture or in the previous lecture, we have got the same direction by using the pole concept or MMF concept. So, it is up to you. You can go by the by this method as well as, or you can go by the concept that we have discussed in the lecture number 9. Alright, now let us discuss the double field revolving theory in the 3-phase. Alright, so in the 3-phase, what we, means to reverse the direction, to reverse the rotation of the magnetic field, what we need to do? Do we need to reverse the winding? No, the direction can only be judged. The direction can only be provided by the current, but not by the winding. All right. So, whatever current we are here at phase A, phase B, means whatever be the placement that we are having for coil A, coil B, coil C, that should be unaltered. Only the current flowing in them will going to be changed. So, earlier we have the current IA as IM sin, IM sin omega t, okay, and IB and IC. But at this time, as I told you in the last lecture, we will have to change the 2 phases current. We will have to change the current of any 2 phases. All right. So, interchange this current. So, just for the sake of simplicity, let me take here cos omega t. So, this will become cos omega t minus minus 240 or plus 120 degree, both are same. And here Im cos omega t minus 120 degree. So, I have interchanged these 2 currents. So, by interchanging, your MMF will going to be changed. See, FA is now become, okay, let me include the space angle also. So, let me write it directly. Your FA will become Fm cos theta cos omega t FB. See, the winding placement here gives an MMF FA, FB and FC. This was the winding placement, and this is the angle theta that we have taken. Now at this part, okay, so means the MMF at an angle theta due to FA will be what? FA cos theta, na, simply. So by using the same analogy, only the current is changing, in the winding, but the space angle with respect to MMF will be same. See, here it will be FA cos theta. This angle is theta minus 120 degree. So this will be FB cos theta minus 120 degree. This angle theta plus 120 degree. So it will be FC cos theta plus 120 degree. So this time with respect to space angle, all the values are same. Only thing is changing is the current. All right. So your FB will be FM cos theta minus 120 degree will be same. Only current is changing, which is cos omega t plus 120. Omega t plus 120. And your FC will be what? FM cos theta minus 240 degree, or let me write minus 240 as plus 120 degree cos theta, sorry, omega t minus 120 degree. Okay, in the lecture number 9, we have seen that by interchanging this current, any two phases current, we can change the rotation of the magnetic field. Let us see whether we are getting the same result or not. So resolving this into two parts, your FA is FM by 2 cos theta minus omega t plus cos theta plus omega t. Let us resolve FB. FM by 2 cos A cos B means multiply by 2 divide by 2. So 2 cos A cos B. So if you add, you will going to get theta plus omega t directly cos theta plus omega t, and if you subtract, consider this is as A and this as B. So theta minus 120 minus omega t minus 120. So you will get theta minus omega t minus 240 cos of theta minus omega t minus 240. Please confirm whether this is correct or not. And FC will be FM by 2 cos of, add 2 cos A cos B. So this will going to be added up. So you will get theta plus omega t plus cos A minus B. So subtract here theta minus omega t and minus 240, sorry, plus 240 I guess. Cos theta minus omega t plus 240 cos theta minus omega t plus 240 is what? Minus 120 degree. So what I did, I have taken this as A, this as B. This as A, this as B, and apply the formula, means the trigonometry formula. 2 cos A into cos b equal to cos of a plus b plus cos of a minus b. Okay, 2 cos a cos b is what? Cos of a plus b plus cos of a minus b. Now, if you add up all this value, to get the resultant FR, see, means FA plus FB plus FC, FA plus FB plus FC. So, the first term, sorry, this term and this term all are same. So, it will going to add it up as 3 FM by 2 cos of theta minus omega not minus plus theta plus omega t plus. Now, add this one cos theta minus omega t, cos theta minus omega t minus 240, cos theta minus omega t minus 120 degree. So, when you add this, you will going to get 0 value. So, with this first term, okay, simply let me replace this with plus sign, sorry, minus sign, and this as plus sign. This is plus sign and this is minus sign. Okay, so if you see that the first term will has been added up, and the second term is what basically will give you the resultant value as 0. So, with respect to second term, you will get 0 here. So, the overall resultant is 3 FM by 2 cos of theta plus omega t. So, see, earlier we have got 3 FM by 2 cos theta minus omega t. Now, by changing the current in the winding, we have got the amplitude as same, but this time we have the inside the cos we have theta plus omega t. So, if this was considered, sorry, where it is? Okay, so if it was considered in the forward direction or in a clockwise direction, then for plus omega, it will be anti-clockwise direction or backward direction. And this we have seen in the lecture number the lecture number 9. By interchanging the two phases current, the direction can be made anti-clockwise. All right. So, again, you can go by that method or by this method. Here you can visualize the amplitude and the rotation at the same time. All right. So, let us move to the last topic, that is double revolving field theory. Double revolving field theory in two-phase winding. So, we have discussed about the three-phase. Now, we are left with the two-phase, and this topic is basically related to the single-phase induction motor. Okay. All right. So, first let me draw the MMF here. This MMF we have assumed as FA in the two phase. FA, this is 90 degree and this is FB. Now, let us take an space angle. Wait a second. Space angle as theta. Okay, and we'll see the effect of both the MMF at this point, okay, at this angle theta. So, what will be this angle? This angle will be 90 minus theta or theta minus 90, both are same. So, your FA component here will be FA cos theta, and your FB component will be what? FB cos of theta minus 90. Done. and the current that we have taken for the phase A current as Im sine omega t, sorry, not sine, let me take cos omega t, and your Ib as Im cos omega t minus 90 degree. Done. So your MMF FA due to this current and space angle will be what? This will be equal to Fm cos omega t cos theta, and Fb will be equal to Fm cos omega t minus 90 degree cos of theta minus 90. I hope you have understood this. Okay, n into I have taken as Fm, and this component I have added up here. All right. So this will be the MMF due to space angle theta and the electrical angle or the time variation, which is omega t. Now let us add up this FA and FB. Just a second. Let us add up F, which is resultant. This is equal to FA plus FB. So this will give the value as Fm cos omega t into cos theta. Fm cos omega t into cos theta plus Fm cos omega t minus 90 degree cos theta minus 90 degree. So if you take out the common Fm, or one thing we can do, multiply by 2 and divide by 2 in both the term. So Fm by 2 comes out, and here you are left with 2 cos A cos B. So cos of A minus B, so theta minus omega t, plus cos of A plus B, so theta plus omega t. From this part, cos of A minus B will be what? Take this as A and this as B. So you will get cos of theta minus omega t, and if you add both these two, you will get cos of A plus B, means 2 cos A cos B. So cos of A minus B, cos of A plus B. So cos of theta plus omega t minus 180 degree. So what is this value? Cos of theta plus omega t minus 180. So this is minus cos theta plus omega t. So this term and this term will be cancelled out. You are left with first term and second term. These two are equal and opposite. So you will get Fm by 2 into 2 times cos of theta minus omega t. So this becomes equal to Fm cos of theta minus omega t. Now here the conclusion will be same, like in the two phase we have obtained the magnitude as Fm, and for the positive phase sequence, okay, means at the phase A current will be Ia, and phase B the current will be Ib, where this Ib current is lagging by an angle of 90 degree. So if you are going to follow this, then your rotation will be what? We have obtained as clockwise. In the same way, theta minus omega t. So this minus sign implies that rotation is what? Clockwise, because theta here I have taken in clockwise direction. Done? Now let me give you a task here. Please interchange the current. Please interchange the current here and see what result you are going to get, a resultant MMF. Definitely the resultant MMF, while interchanging the current, you will going to get Fm cos theta plus omega t. Please do practice this thing, and definitely you will come to know the idea hidden behind this. All right. So with this we have completed all the basics requirement for the electrical machine, and I hope you have enjoyed throughout this foundation course of the electrical machine. And those who are new and who have not attended any lecture of the electrical machine, please do visit from the lecture 1 to till the last lecture, which is lecture number 10. Definitely, my friend, you will going to enjoy a lot. And whatever doubt, if you are means whatever doubt you are pending with it, or whatever doubt that you are having, definitely will going to be clear at instant. Okay, at instant, whatever doubt you are having will be clarified. Just go through all the videos and definitely you will enjoy a lot. All right, so please share the session link with your friend, and if you liked or enjoyed the session, and please hit the like button, as well as if you are new to our channel, please do subscribe to our IMS GATE Academy channel, so that whenever in future we are coming live, you will going to take an advantage, or you will going to have a benefit of all the initiatives that we are going to take. And also do not forget to press the bell icon, so that whenever we are coming live or whenever we are coming with a new initiative, you would going to instantly notified. All right, so bye bye, take a very good care of your health, and all the very best for your GATE exam.